werde heute über was ein bisschen Merkwürdiges sprechen. And I'm going to speak in English now. So, I'm going to talk to you about 2D and 3D parametric CAD, so 3D designs in JavaScript. So, you can see a first example here, and there's a box with prints that you can take with examples of 3D printed things that were designed in JavaScript. So it's, I'm going to try to not make it too complicated and long, and you can ask me any questions you want. So the first part is, it's a very simple concept. You create design by coding. So you just write a function, main function that returns other functions which return shapes. So this is a cube, for example. So you can use any code editor, and you just, well, pass it to the editors, and then it creates the geometry. So you have a library of parts, you have 2D primitives, so rectangles, you have circles, you have polygons and paths, so various little shapes. You have also the same thing in 3D, cubes, spheres, and cylinders. And also a lot of various other things. It's a big API, so I won't get into the details. You can also transform your objects. So you can see here, I think it's readable, you can translate, so move things around, you can rotate, you can scale, and you can apply transformation matrices. So combining all your transformations. So translate, rotate, scale, and very important, this is all immutable. So every time you apply an operation, you actually return a new object. This is very important because it's at the heart of the whole system. So once you have all the basics, you can apply CSG operations. Has anybody played Quake or something like that? Yeah. So it's the same principle. The brushes and things like that were just basically a variation of this. So you can apply unions. So you combine objects. So you can see that there in the bottom corner. You can do intersections, so only keep the parts that are common to shapes, and you can do subtractions. So because everybody wants to design things with holes in them, of course. And it's still immutable. So every time you do something, it's always a new object that gets returned. So before anybody says that immutability is bad or something like that. So you also have various operations with which you can change 2D shapes into 3D shapes and do complicated things. Up top is a rotate extrude, so you take something and you move around in a circle basically. You can do linear extrusions, so you take a flat shape and you move it upwards. You can twist it, you can do rectangular things, and this is a kind of very special operation which every time you do something, you can do a different shape. So, a bit complicated things. You also have what it's called a hull or a chain hull right there. And that's basically taking, like you would wrap something. So, like you would put things in a bag and squeeze it real tight around the shapes. You also have connectors and a lot more things, but I won't get into that. So, this is always just simple JavaScript. So, this is a very old project that started years ago. It used to have lots of bad JavaScript code. I'll get to that in a bit. But it's still just JavaScript, so you can use ES6 features, whatever in this day and age. It was always based on a very low amount of dependencies. It even had no dependencies at all until recently. But that's not really sustainable. That's another problem. And it's just functions. So functions return shapes, functions transform shapes. It's just that. There is a set of classes and objects deep down, but that's not the ideal way of manipulating things. So the thing is, you have seen the box of 3D printed parts. So the advantages is you code JavaScript and you end up with objects, actual physical objects, because you can export things, and I'll get to that. So you first create your design, you run it through the pipeline. I'll get to the different tools that you have. And you get different export formats. and then you pass it, for example, to a 3D printer slicer program that creates parts ready for 3D printing. For example, I created a small tag for tonight. You can take one, by the way, you can keep them. And it was created with the following code. So I'll get a bit into the details. So you just get a set of parameters. You create, again, measure text is just a function returning a specific structure of text data, 3D data. You then have circles, you do translate operations, and you just return a final object which gets then generated. And this is the result. And as you can see, it's quite close to what you have in your hand. And then you send it off to the 3D printer, and it prints the part. And this is it. And this is just about, I think, 150 lines of JavaScript, and most of it is not optimized. And it's all parametric, so if you look at the previous slide here, you can see you can actually define what you want to be able to be changed. So you can have numeric parameters, colors, anything you want. And a lot of people are actually using this because it's actually, I think, 7 years old. So there's lots of designs that you can find online. And you also have some of the other things printed. And it's not just for 3D printing, because people create things out of cardboard boxes. So they create the design in JavaScript, and then they export it and flatten it, and then generate other shapes. So there's lots of variety in how people use it. So next part up is the tools, because it's starting to become a bit of an ecosystem. So this is what it started with. So a web-based, purely client-side, and I do mean purely, so there's absolutely no server component. Any web server can host it because there's no dependency on anything. So the interface won't win any beauty awards, but it works. And as you can see, this is just designed with all the parameters, with a bit older code, still vars everywhere, something like that. You also have a command line using Node.js, where you can pass your script, and it outputs various files that you can then print or do whatever with it. There's also, since 2 months ago, I worked on an Electron-based front end with a newer 3D viewer, and finally Node.js module support, because as it was client-side purely, there was no Node module, which is kind of a problem when you want modular code. Also, and I'll get into that in a bit, we started spinning up the huge code base into a lot of very specialized packages so that you can use what you want and not more. Also, the interesting thing is, even though it was, to be honest, a horrible piece of JavaScript originally, it was very outdated, a lot of people create tools from those tools. So, for example, customizable Raspberry Pi boxes, or jewelries, or cookie cutters, or something for kids. So, does anybody know Blockly?
Yeah.
Okay, so somebody at Microsoft created this interface to teach kids how to code objects. Because they have workshops where they create code using Blockly, so they don't have to write the code. And then at the end of the workshop, they print the parts, and kids go home with the parts they designed. And my kids also love these kind of things. So, as I said, it's a rather old project. So it started in 2012. So by JavaScript standards, that's pretty much prehistory. And a lot of people worked on this. There were like successive layers of things added and changed. These were very important people in development. And currently there's 2 main developers. So me and an American guy actually working in Japan. So it's kind of fun to do different things.
So you can code 24 hours.
Exactly. If we didn't have jobs and families. And, so there's also been a lot of smaller contributors over the years, smaller or bigger, but still. So I joined the project. I actually created a fork around 3 years ago in CoffeeScript. when it was so cool, and it was, looked like Python, so I liked it. Anyway, so I created a fork a few years ago, but I decided to drop that and join the main project. But it still was basically in a rather bad state. So the question is always, I think you faced this before, do you upgrade the old code or do you ditch it? So yeah, or start from scratch. And then you discover there are no unit tests. There are many files with over 1,000 lines of code. There are no modules. It's all a single file everywhere. And there are globals everywhere, so everything is injected into the window, and it's just whatever. So it looks like this. This is actually rather accurate.
It's terrible.
So in the past year, basically with Jeff, the other guy, we spent a huge amount of time. Perhaps this was not the wisest decision, but in the end it's kind of working out. So splitting it up, cleaning it up, bringing it to ES6 whenever possible. I'll get to that. Adding unit tests, because it turns out without unit tests, everything breaks once in a while and you don't know what happens. So it's really fun. So the thing was also to really embrace the JavaScript ecosystem, Node.js and everything, which wasn't the case before. It still used make files and things like that, so it was a bit special. So Browserify is our main tool. Don't try to sell me on Webpack, please. I try to use it. I'm not a fan. We also added automation via CI, and we recently started to switch to monorepos via Lerna. Did anybody use Lerna? Cool. And honestly, it really saves us a lot of time when doing releases and things like that, so it's getting in the right direction. We also tried a few things. So for example, we tried to do more advanced ES6 features with Babel, transpiling and everything. But in the end, we kind of switched back to a more minimalistic view of things. So only using what's available from Node 6 and onwards. And the recent browsers, since now ES6 is everywhere, it's actually not that much of a problem. But for example, ES6 modules are out. So we actually reverted the code back from that. So, and this is because we have very little time. So we have found quite a few issues with transpiling when you have a big pile of code. When you do dependencies, you have client side, browser side, command line. In the end, it proved to be too much. So we're not quite there yet, but we're getting there. So, as I said, yeah, it was purely client side. It still tries to be that because a lot of people without JavaScript knowledge use it. So they are trying to learn JavaScript by coding their designs, but they have no technical background on how to install things, and even Node.js is a bit of a hurdle to a lot of people. So it's always a question how to deal with modular code, and I mean modular code for designs. So you could normally want to do, for example, my bottle would be a design, and you want to require that in your design because you want a pack of bottles, which is your design. So ideally, we are going to switch progressively to using node modules as well. We'll very likely use a fake require function in the browser and use the standard Node.js tools in the rest. So we still need to have it very accessible, again, because of the different levels of people that use it. So we can't force new features on people because there's a big user base, so it's a bit delicate. And again, so some people are absolutely very, very skilled, so they can do insane designs and very advanced JavaScript features. They make use of honestly better ES6 things than I would do. Some people just don't. They just start with this using JavaScript, which is a quite actually nice introduction. So we always have to adapt and keep this in mind. So one of the fun things as well is historically there were two APIs for people to code. So one which is more object-oriented with things attached to the prototypes of the basic objects, the underlying structure, and a more functional-oriented thing which you can see always on every second line. And so the problem is we can't maintain two APIs because one of them is broken in one way and the other is broken in another way. So this is just not possible. So this is one of the things we're trying to move towards V2, which kind of breaks some things, but it's kind of a difficult path. So we want to do functions first, ditch absolutely every prototype-based things, and keep it only internally. And the problem, of course, how do you deprecate progressively or not an API that has literally hundreds of functions? So it's kind of a difficult game to play, so we're still not completely there. And of course, we want also to apply semantic versioning to our API, because, well, we need to tell the users some way that their designs are going to be broken at that point with that version of the API. And the interesting thing is we discover new things in the old code every day. So it's like programming geology. Oh, I didn't know it even made coffee and things like that. So you discover new things every day and you realize that it's still not 100% tested. Some things are now 90% covered, but there's still hidden mysteries everywhere, and we're trying to get away from that. And I forgot something. So anyway, one of the last point is that, well, JavaScript is not always very fast. So while we do use WebGL for the front end, the creation of 3D geometry that's actually watertight, because you can't 3D print something that has overlapping faces or things like that, it's extremely complicated. So there's the issue of you have quickly very big geometry complexity. Also, I'm sure you all run into that at some point when you do unit testing with very precise floating point things where you have some things off by 0.001 or something like that. So it's a joy to work with when you're doing tests. Also, since a lot of the code is extremely old, we are not aware always of the original intents of the things that were created. So we're trying to find new approaches. Has anybody used Esprima, for example? Or generated or manipulated JavaScript ASTs, so abstract syntax trees? You should. It's a wonderful tool. It's like magic. So, for example, that's one way we could do to actually increase the performance. Right now, it's brute force. It's like React. You put data in, and you run it through the geometric processing thing, and it comes out. There's no intermediary. There's no optimization. There's nothing. So it doesn't actually make sense, because when you code, as you all know, you do small changes. You do incremental things. But right now, it actually recomputes everything all the time. And when every operation takes a few seconds and you want the immediate response on your screen, that's not acceptable. So we're experimenting with ways to evaluate a portion of the JavaScript instead of re-evaluating everything and just using an abstract syntax tree representation of the code. Also, now, I never know how to pronounce it, WASM, WebASM, or whatever, is a solution also perhaps to actually brute force on the CPU some of the calculations, because otherwise they're too slow. And then there's GPU. There's absolutely wonderful things that can be done in WebGL, but it's still lagging behind OpenGL, so there's no geometric shaders and things like that. So we're still stuck, and in the end we still need 3D files actually computed on the CPU partially to be able to be exported and reused. That's not always true, but still. So, as I said before, a very important part of what we're aiming for is to be able to reuse designs and to publish them on NPM, and to actually provide perhaps a user interface on top of NPM for users to publish their designs. We do not want to reinvent the wheel, we have no time for that, and reuse as much as we can. So the mantras are really less is more. We're trying to minimize the API, minimize the amount of work, and it's always more. And this is also very important. I am sure that some of the people that have used Python before have heard of this one, but it's absolutely true that every time you have some implicit thing in the code, it tends to explode in your face. So we're trying to aim for something clear. Also to add documentation, because we have barely got a documentation, which is bad. And if you have any questions, please do. And perhaps I should have switched these around, but really people have been very helpful. They sent me some designs, the one that I used basically for the name tag and things like that. So this is a very lively community, so that's very nice. So, Dankeschön.
HannoverJS actually is a community of people around the world who have contributed to the code base. And while that was just a small mentioning of the group, how many people are there roughly that actually do something from time to time? Or is it actually just you and
well, we're doing
sometimes something pops out from the community?
Exactly, that's the kind of a problem. We're doing most of the work. Occasionally, people will do a push of big changes, and really, I think it depends on what they need. So if they have a need and they see a way to fix things, then they will propose a lot of interesting changes. But it's more like occasional bursts. And if you want to contribute, please do, because we can. Yeah, and it's very promising. I didn't mention this, but something we also started looking at is Beaker browser and that protocol. Somebody heard of it? So basically, it's a browser built around a peer-to-peer protocol, and it would make sharing designs very easy because they would be self-hosted because the browser actually acts like a host. So this might be one possible solution to do purely, I really put quotes around that, purely client-side sharing.
But there's your JIT repository, right?
Yes, yeah, there's
many,
sorry, no problem. There's more than one repository. It's a set of 2 monorepos and one separate thing for the geometric core, which is a single repository. And by the way, you can always try it out live if you want to, and have fun breaking the thing, because you can always find bugs. But all jokes aside, you can find various examples directly, and you can test them. Most of these examples actually work in a rather fast way, so you can, for example, create gears that you could change. So you can, I don't know, set gears to 20, and then it will recompile the thing. And this would be printable out of the box straight away. And yeah, there's a lot of different things. The other design, you can really do. I'm not much of a designer. I just try to do small robot things and things like that. But some people really do nice things.
I just wanted to ask how you found the project, or how, if you have any affiliation to making this stuff, or.
Yeah, I actually started to do 3D printing 7 years ago, and this is very important in the acknowledgements I added. Originally, there's a program written in C++, which is OpenSCAD, which was the inspiration back then. And well, of course, with JavaScript you can run it everywhere, so you can actually live with the downsides of the speed. Also, the fact is, OpenSCAD is actually not a complete language. It's made only for modeling, so you don't have all the nice things in JavaScript. For example, until recently, it didn't even have variables, something like that. So it came naturally, and actually, I started working on these kind of things, so 3D modeling in the browser, because I couldn't get OpenGL to compile correctly on my machine. And with WebGL, it just worked. So JavaScript and WebGL, that's the same. I can show you very quickly the desktop app. It's absolutely extremely easy to get things running. And this one is using a bit of different set of technology, but the core is just the same. And it's using null modules, and this is the design. It was
Electron?
Yeah.
Yeah.
Is this not running on GPU or CPU?
both. The visuals are actually on the GPU, but it's the geometric data itself is computed on the CPU and then transformed. It's a bit of additional work, but actually transforming the raw geometric data to the GPU is not significant.
And could you now add like a exclamation mark at the end, or
Yes.
how is it? Oh, cool.
And there's HannoverJS on the other side. But I cheated with that, it's hard-coded. So I didn't want to add a second text box, so it's just... And the interesting thing is I could change it live. For example, some of the colors are hard-coded, and even the captions are done in a weird way, but I'm just going to change this, and it will automatically update. Also, there's a file watcher which also watches all the dependencies because of the fact that it watches the whole required tree to see for changes. So, for example, there's this robot body beginning also, and you can also add thing like that. So, as you can see, every time I use the checkbox or thing like that, it actually recomputes everything. And this is a more complex design. I don't know if you see, but the cylinders are quite smooth, and the smoother they are, the slower it gets, because it needs to compute the Boolean operations for every single facet, and there's of course subtractions going on for every single one of them. And this is abnormally slow, so I might have done something bad. And the good thing is, at least in the Electron app, it's very easy to debug the code because you can just enter it and actually debug your 3D designs, which is considerably easier than in the browser because that one still uses sort of weird hacks. And as you can see, the quality is quite nice again. I hard-coded the resolution, but one solution is to not have it hard-coded. So for example, you can see this is a robot body, and you would have for those that actually play around with these kind of things, the servos will be in all 4 positions. And each different part is actually a separate node module. So for example, body top is just a function that gets exported, and as you can see, it's not that complex. It takes a while of getting used to, of course, to code designs, but it's still relatively trivial. And with ES6 and destructuring and things like that, it's honestly really, really pleasant. And we're keeping an eye out on the pipeline proposal. I don't know if somebody saw that, but basically having the ability to pipe operations in JavaScript directly, like in Haskell or in Lisp or so. It would be really nice because typically you chain, scale, transform. So anyway, there's also, for example, modules for bolts, modules for servos, and then you just require it, and then there you have the design.
So there's absolutely no interest of you in changing some parts of the code base into a faster, to use a faster language, or some operations specifically using a faster language, or to just add like a module that's using language like C, Rust, or RHEL to have internal structures of the 3D models that can compute it faster, but in the end can return a JavaScript object?
That's the main question about Web ASM. The thing is, it still needs to run in the browser, and for now, what I looked at, it's not there yet. I tried mscriptum 3 years ago, and it wasn't quite ready for deployment in the browser. In Node, it would work. In Electron, it would work, but it's still. Ironically, somebody recently told us they had a very nice, a tiny one-line change that increased computation speed by 15% in some cases, and they told us that even while they were C++ developers, and they told us that the algorithm we're using is one of the most optimal ones, which is scary because it's not fast. Let's just say that. So this is why this is a possibility, but also, for example, we could cache the geometry of the objects.
Yeah, that, for example, would be a nice enhancement of the user interface. So every time you make a change, you show something, that will up to but actually that would be some solution that you can manually do steps, for example, but you will use the script interface.
Exactly, but it's actually not that trivial to do the AST analysis and to determine exactly what part of the code changed. I think it's feasible, but I'm not full time on this, so this is
Sure.
not possible.
Contributing is quite interesting in this particular case.
So feel free to, if you have feedback, please send us a message. Don't hesitate to file a request on GitHub because we're quite reactive to things, without jokes about reactive programming.
Are there any, like, I used to, like, in school time for some weeks, I worked at a company in an internship and they used AutoCAD.
Yes.
I think this is like the market leader and like most professional. Are there any like major differences? Like something you cannot do with one of them but with the other one? Do you know of any or?
They have millions of dollars in research.
Yeah.
But with more work, you could actually do a lot of similar things. One thing that is not possible for us is fillets. I don't know how you say it. When you join two parts and you want to have something like this, you know, or a small automatic rounding to make the part stronger.
Bevels.
Yeah, bevels and things like that. Those are extremely hard to do with this, but it's actually possible. But it's way more complicated. And yeah. The geometric engine they have is way faster. There is one company that does web-based 3D modeling, but actually all the computation is server-side. They have wonderful UI, it's absolutely great, but again, they are old AutoCAD people, and they have, I think, 50 million investment in dealing with this, so we can't compete. But it works, so.
Yeah.
What is your use case and which problem are you trying to solve with OpenSCAD?
Well, the use case is you want to model parts typically for 3D printing. That's the most often things.
By typing the code, not using the UI like in AutoCAD.
I must say I don't like UIs usually.
Okay.
So I'm a very command line guy, but also code can be much more descriptive because imagine you just have a loop that returns objects. That's something that's very hard to do in a visual language. And we are going to add some more visual things to this, but typically it's really for programmers, and there's some things that really cannot be done in a graphical UI that you can do in code. It's you can do, for example, even here, the definition of the cross and the angles, this is computed with just math. And it's just modulos, math, cosine, very basic math, but you can do something that if you had to do it visually, it would be very hard to do. And also the thing is you just provide parameters and you can have very different design. So there's a recent contributor that's actually dealing with AI and virtual environment for AIs that actually uses OpenJSCAD because he can generate a ton of different virtual environment and geometries using the code. Because he just has to provide a set of parameters and then he can generate a lot of different geometry, which again you couldn't do with a visual interface. So he just runs basically the command line interface, provides the parameters, and he has a ton of output files that he can feed to his programs.
There's a tool, I don't know the name of this tool, but this tool provides you Python to script your models.
Blender, is it?
Blender, yes, that's right. So some kind of alternative to Blender, right?
It's a bit different. Here it's really, you have to think of it as a single function to which you provide the parameters. So Python scripting is more like adding some specific parts to automate some tasks, but here it's more the whole stack of the things that are like that. So, because it would be extremely time consuming for us to develop a UI that's really as complex as Blender, so it's not really the same flavor.
Sure. So someone dropped the name Blender. Are there third-party exporters or something like options to open it in different programs? Because like smooth transition between JSCAD and Blender probably would make this software widely available, widely known in communities like Blender users, for example.
Well, there's we have quite a lot of formats that we support. There's no Blender export because it's sort of a different logic, so it wouldn't quite map one-to-one. But you can export STL files, which is the
well, Blender can import it.
Exactly. So it happens. For example, we had problem with mesh structures. There were some operations which created degenerate meshes. So I just exported STL and imported to Blender to check out the points where there were issues. But yeah, you could, in theory, of course, write some more complex exporters. For example, Jeff, the other person that works on this, actually created full, well, not full, but reasonably complete DXF importer. So we already have some pieces of the DXF export, and since that's sort of the main format for 3D files, it's kind of, well, we're adding piece by piece, and that's one of the things that people contributed. So specific formats, for example, X3D. I have never heard of it actually before a few months, and apparently it's a VRML sort of child of VRML. So yeah, we have AMF, OAG, STL, SVG, AMF, and the other end as well, and that's pretty much it. Yeah, and X3D, of course.
What are you currently working on? What branch of the software?
Right now, I'm working on the desktop version and on the node module support. So.
Node module. It sounds terrific.
We really hope that there's a lot of people who create design, but there's basically no place to showcase them. So yeah, that's one thing. So a new site basically with documentation, because we have a wiki, but it was an external wiki and the people don't react to it anymore. We now have a new wiki since a few weeks ago. So documentation, API simplification, and node support, so node module support. Those are the main things. Then there's other stuff, more the AST analysis. That's a few months away at least. So it's not there.
For creating the geometry, are you already using multi-threading, or if not, is it possible?
What we're using is actually everything runs in a background thread. The problem is it's actually very close to the AST problem. So to do multi-threading, you need to be able to split up the thing into independent pieces, which actually, for example, even I'll show you even the logo, which is very simple. It's just the difference between a cube, a sphere, and an intersection of a sphere and a cube. So this, in theory, could be run in parallel, and you're right, it would be way faster. The problem is analyzing the code to to determine the independent parts. And that's exactly what the AST analysis is supposed to do. Basically generate a CSG tree. I don't know if you guys remember the picture that I showed where it was decomposed into different operations. And that's what we need to be able to replicate from the AST data. And then, yes, that's the idea. We will be able to run everything in parallel, only swap out the things that need to be swapped out, and that would be way faster already.
So when you're writing the difference of a cube and a sphere, you're not turning the cube into geometry and the sphere into geometry, and then the difference operation is working on the geometry.
Yes, it is.
It is.
Yes. So it's basically, it first generates the cubes and the spheres, and then it applies the operations. It goes, how do you say, bottom up. So the more deeply nested things are evaluated first, and then it goes up.
Okay, but so wouldn't you be able to evaluate the cube in one thread and the sphere in another? Then
Yes.
yes, but it's still hard to decide where to split or.
Exactly, because I recently tried an implementation of an analysis thing that would split out these things. For now, honestly, I'm exploring. There are some node modules that allow you to evaluate a portion of the program, which is very promising. But you imagine if I add just this. If I say, let's just say, the same size, and then you do it like this. This means that this relies on an external variable which you need to also pass to that independent piece of code, which makes it, of course, a bit harder because you need to extract all the dependencies of the variables.
Okay.
Why don't you simply create a tree structure from the code and use a tree diffing algorithm, like, for example, in React, to diff those trees, and then you render the object structure. Then you don't need AST processing because in the end AST processing is probably impossible, because you have a Turing complete language. You can't decide everything from an AST. It's impossible. So if you render it to a structure first, then you have a static structure, and then you can use tree diffing, and then you can decide which parts you combine, for example, or patch or something like this. But using AST, I can't imagine that this will ever work.
Well, both two things. You're right. I actually played around with the idea of basically not having any node return. So let's call spheres and differences a node, not having them actually compute the geometry but return a structure. The problem is that requires modifying every single part of the code. And since we're already changing a huge part, it's problematic to do it at the same time. But ideally, yes, it would make it simpler. But the one advantage of the AST is that it doesn't need to have any knowledge of the internal workings or change it. So it's a bit of a trade-off. By the way, there's a lot of interesting things possible with ASTs, which I already had working prototypes for. For example, being able to trace the code so that you could you select in the editor here, for example, the cube, and it would highlight the cube in the 3D view. And also the other way around, having visual things that allow you to move things visually and then generate the code back. Because that's also one of the advantages with playing with AST, that you can generate things from it. So yeah,
but in the end, I think it's nearly impossible, because you can use any function, any operation possible in JavaScript. It's really impossible to do differing on those complex structures and so on. So I think in the end it will be possible better to do a structure-based approach. And because then it's quite easy to do tree diffing.
Yes, because we only have the tree that we need in that case. You're right, but as I said, this is the problem with this project, is we try to only break things bit by bit, so it's a bit hard.
Okay, any more questions? So if not, so thanks Mark again.